The objective for Section 3 is to identify basic container shapes that indicate the presence and hazards of hazardous materials. With basic container shapes, once you recognize that a location or occupancy may have hazardous materials, the presence of certain storage vessels, tanks, containers, packages, or vehicles can confirm their presence with certainty. These containers can provide useful information about the materials inside, so it is important for you to recognize the shapes of the different containers and packaging in which hazardous materials are stored and transported. The section that follows will introduce hazmat containers information such as container names by transport mode and capacity, pressure containers, cryogenic containers, liquid containers, solid containers, radioactive material containers, pipelines, vessel cargo carriers, unit loading devices. Be familiar with the container names by the transport mode and capacity. Hazmat containers are sometimes classified according to transport mode. Highway cargo tanks, rail cars, vessel cargo carriers, and intermodal containers that transfer between modes. Containers can also be classified by their capacity. Bulk packaging refers to packaging other than on a ship or barge, in which materials are loaded with no intermediate form of containment. This packaging type includes a transport vehicle or freight container such as a cargo tank, rail car, or portable tanks. Intermediate bulk containers, sometimes called IBCs, and intermodal containers, also known as IMs containers, are also examples. In order to meet the criteria for bulk packaging, one of the following must be met. The maximum capacity is greater than 119 gallons as a receptacle for liquid. Maximum net mass is greater than 882 pounds, or maximum capacity is greater than 119 gallons as a receptacle for a solid. And the water capacity is 1,001 pounds or greater as a receptacle for gas. Non-bulk packaging is similar than the minimum criteria established for bulk packaging. Drums, boxes, carboys, and bags are examples. Composite packages with an outer packaging and an inner receptacle and combination packages such as multiple packages grouped together in a single outer container, such as bottles of acid packed inside a cardboard box, may also be classified as non-bulk packaging. Most people are familiar with pressure containers such as compressed gas cylinders. Compressed gas cylinders are pressure containers designed to hold product under pressure. The product may be a gas, liquid gas, or a gas dissolved in a liquid. Pressure containers has a potential to release a great deal of energy if involved in an incident. For example, when stressed, pressure containers can rupture violently due to internal pressure. This can be accelerated if exposed to heat, flame, or mechanical damage. When released, the product will expand rapidly and will travel based on the product's physical and chemical properties and the environmental conditions. You may not be able to see if the contents of the pressure container are leaking, nor where they might be going. Warning: stop. Products stored in pressure containers may kill you. As a responder, your job is to stop and stop others, isolate and deny entry. Also, when damaged or stressed by heat or flames, pressure containers may explode. Keep your distance. Another warning is that contents of pressure containers may ignite easily and will expand quickly if released. Keep your distance upwind, uphill, and upstream. Remove ignition sources if it can be done safely. And finally, contents of pressure containers may be corrosive and will expand quickly if released. Keep your distance. Remember, uphill, upwind, upstream. Regardless of size, transportation mode, or content, clues to pressure containers may include rounded, almost spherical ends, bolted manways, bolted protective housings, pressure relief devices, and pressure gauges. Cryogenic containers are designed to store and transport cryogens. A cryogen is sometimes called refrigerated liquefied gas and is a gas that turns into a liquid at or below minus 130 degrees Fahrenheit at 14.7 pounds per square inch. These containers may be pressurized, though not to the degree of pressure containers. When released, cryogens may transition from liquid state into vapor state, and this reaction may happen rapidly, and a spill or leak will boil into a much larger vapor cloud. These vapor clouds may be flammable, toxic, corrosive, or an oxidizer. Some cryogens may present multiple hazards. Additionally, cryogenic vapors can be extremely cold and potentially cause freezing burns, which are treated as cold injuries according to their severity. Any clothing saturated with a cryogenic material must be removed immediately. This is particularly important if the vapor is flammable or an oxidizer. A first responder cannot escape flames from clothing trapped vapors if they ignite. A warning is that cryogens can displace oxygen and cause asphyxiation, and they are extremely cold and can severely injure you if contacted. And again, use caution and immediately remove any clothing saturated with a cryogenic material. Regardless of size, transportation mode, or content, clues indicating cryogenic containers may include the following features. Contents such as liquid oxygen, otherwise known as LOX, nitrogen, helium, hydrogen, argon, and liquefied natural gas, also known as LNG. Another clue is a box-like loading and unloading station attached to the transportation containers. Some common liquid containers include bottles, gasoline containers, paint pails, and drums. However, at fixed site facilities, liquids can be stored in containers that hold many millions of gallons. Large quantities are also transported in tanks via highway, rail, and other modes. Many liquid containers will have some pressure due to the liquid's chemical and physical properties, but these pressures will be lower than a pressure container. Although the pressures may be low, they can still be dangerous. Liquid containers may hold contents that have a variety of hazards, including pressure, heat, often the contents will burn, reactivity, corrosivity, and toxicity. Some liquid containers, when exposed to heat or flames, may rupture violently or explode. A warning, stop. Products in liquid containers may kill you. Your job as a responder is to stop and to stop others, isolate and deny entry. And another warning is that liquid containers may explode when damaged or stressed by heat or flames. Keep your distance. And be cautious because many liquid containers will have low amounts of pressure. When released, this pressure may cause contents to splash or spray. Regardless of size, transportation mode, or content, clues to liquid containers include the following features: flat or less rounded ends of tanks, access hatches secured with easily removable latching devices, low pressure rail cars, may have multiple fittings visible on top. Intermodal, flexible intermediate bulk containers and rigid intermediate bulk containers are designed to be stacked. Flexible bladders filled with fluids. Just remember that highway cargo tanks will have oval, upside down, horseshoe shaped or circular shaped ends with less rounding than pressure tanks. With solid containers, some containers used to hold liquids may also be used for solids. For example, such as drums and bottles. Some transportation containers are specifically designed for loading and unloading solids, and certain fixed facilities may store solids that are not typically deemed hazardous but may present a threat anyway, such as grain, silos, and storage facilities. Hazardous solids may be dust, powders, or small particles. Solid containers typically do not carry any pressure. A powdered pesticide is an example of a potentially toxic solid. Boric acid and sodium hydroxide are corrosive solids. Dynamite is an energy-releasing solid. Calcium carbide is a reactive material that, when in contact with moisture, will release a flammable gas. Small airborne particles that burn but may otherwise be harmless can be dangerous if ignited in an enclosed location, causing a dust explosion. Grain, flour, sugar, coal, metal, and sawdust are examples of these particles. For that reason, you should be aware that fixed facilities where these materials are used, processed, or stored should be considered containers for purpose of this section. Solid materials can also engulf you, causing suffocation and/or crushing injuries. These situations, typically associated with soil, dirt, sand, and gravel, but are also a concern at incidents involving large containers of grain, powdered substances, or flowing solids. Regardless of size, transportation mode, or content, clues to solid containers may include the following features. Transportation containers and systems designed for pneumatic loading and unloading, open tops on hoppers, bins, or other containers, sometimes covered with tarps or plastic, and V-shaped sloping sides with bottom outlets. Warning, just remember, dust explosions can kill you, and solid materials can engulf and kill you. With radioactive material containers, all radioactive material shipments must be packaged and transported according to strict regulations designed to protect the public and the emergency responders from radiation hazard. The packaging used to transport radioactive material is determined by activity, type, and form of material being shipped. Depending upon these factors, radioactive material is shipped in one of 5 basic types, listed from least radioactive hazard to the greatest. The accepted packaging is used only in transportation materials with very extremely low levels of radioactivity that present no risk to the public or environment. An industrial container will retain and protect contents during normal transportation activities such as laboratory samples and smoke detectors. Type A packaging must demonstrate the ability to withstand a series of tests without releasing its contents. Type B packaging must demonstrate the ability to withstand tests stimulating normal shipping conditions and must also withstand severe accident conditions without releasing contents. And finally, Type C packages are very rare and are used for highly activity materials transported by aircraft, which could include plutonium. Use caution. Radiation can travel in all directions for long distances and may pass through materials. It cannot be detected by the 5 human senses and requires a meter to detect it. With pipelines, many hazardous materials, particular petroleum varieties, are transported across both the United States and Canada in underground pipelines. Pipelines may transport liquids or gases. 3 things must be on a pipeline marker: what it is carrying, who owns it, and a 24-hour contact number. Where pipelines cross under or over roadways, railroad waterways, the pipeline companies must provide markers. These markers are often the best way to identify that pipelines are present, as well as to identify their contents. Markers must be in sufficient number along the pipeline to identify the pipe's location. However, pipeline markers do not always mark exact locations and can be off by 50 feet either way. And you should not assume that the pipeline runs in perfectly straight line between the markers. As a warning, pipelines can transport high pressure materials and may explode. And as a warning, that pipelines can transport a variety of very dangerous materials. And as a precaution, just remember that pipelines may be buried in residential neighborhoods. With vessel cargo carriers, there are marine vessels that transport over 90% of the world's cargo, and that amount is expected to increase in the future. Hazardous materials incidents involving vessels can be minor, such as a small spill at a port during loading or unloading, or major, such as a small spill contaminating miles of a river or coastline markers. Statistics show that most oil spills are relatively small and are the result from operations such as loading or unloading and normally occurring in ports or at the oil and chemical terminals. Vessels that transport hazardous materials include the following: with tankers or tank vessels, which may transport very large quantities of liquid products. Tankers often carry different products in segregated tanks. There are three types of tankers, which are petroleum carriers that transport crude or finished petroleum products, chemical carriers that transport many different types of chemical products, and liquid flammable gas carriers that transport liquefied natural gas and liquefied petroleum gas. Cargo is shipped in the following four cargo vessels. These are bulk carriers that may transport liquids or solids. The second is break bulk carrier, may transport a variety of materials in many different containers such as pallets, drums, bags, boxes, and crates. The third is container vessels, which transport cargo in standard intermodal containers with standard widths and varying heights, lengths. And finally, we have the roll-on, roll-off vessels that have larger stern and side ramp structures that are lowered to allow vehicles to be driven on and off the vessel. Barges are typically box-shaped, flat-decked vessels used for transporting cargo. Towing or pushing vessels are usually used to move barges because they are not self-propelled. Virtually anything can be transported on a barge. Some barges are configured as floating barracks for military or construction crews, where others are designed as bulk oil and chemical tankers. Some can carry liquefied natural gas in cylinders that may not be visible until you aboard. Barges may serve as floating warehouses with hazardous goods, vehicles, or rail cars inside. As a warning, confined spaces in vessels can contain oxygen-deficient atmospheres that can cause asphyxiation. Unit loading devices, also known as ULDs, are containers and aircraft pallets used to consolidate air cargo into a single transportable unit. They are designed and shaped to fit into airplane decks, components, in particular commercial cargo planes, and in some cases, they may be stacked. Hazardous materials may be shipped in ULDs provided they are in accordance with governmental regulations, including packaging and labeling requirements. Note, just remember that military aircraft or transport vehicles may transport internal airlift and helicopter slingable units, also known as ISULs, that could transport anything, including hazardous materials. The review question for this section are: how can you differentiate pressure, cryogenic, liquid, and solid containers from a distance, and what types of materials are each likely to contain? See pages 54 through 66 of the manual for these answers. List the 5 basic types of containers used to transport radioactive materials and briefly explain what these packages are designed to withstand. To find this answer, look on page 67 of the manual. What types of hazardous materials are transported in pipelines? See page 67 of the manual for this answer. And last, what are unit loading devices, and can hazardous materials be shipped in them? To find this answer, look on page 77 of the manual.